Okay. Uh, I hope this QSR slide is visible to you. Last time I mentioned that I will give you soon the assignment number 2 and 3. So in the assignment number 2, if you know till now what is exactly QSAR, so it is dependent on molecular descriptor. So you need to evaluate molecular descriptors using some software. Okay. So last time I talked about that software, I will talk in more detail today. So let me start asking some question to you. Just a minute. Okay. So if you know QSR, what did we say exactly? What is this method? Can you say something about what is dependent on what? Okay. So activity is the function of molecular descriptors. This we can write in terms of this equation. Activity, which is when we are dealing with the drug design, we call it to be a biological activity, or it can be any property also. So it is the function of some molecular descriptors. So what you are going to do using the computational software, you are going to predict these molecular descriptors and stuff, and so that you can get this QSR model. So if I write this as some equation like activity as capital Y, and this molecular descriptor I can write as some X. So if I want to write this as A0 as some constant, A1, and molecular descriptor as X1 plus A2 X2 plus similarly I can go to any number. Okay. So here if I want to ask you like the activity value or Y, from where will I get these values, the activity value? If you want to do the modeling, the activity value, whether you are going to get it somewhere or you are going to estimate it.
For some compounds we are experimentally determining, and for some compounds we are estimating.
Okay, good. So we can consider that we should have some initial values. So these initial values for some compounds we should have the data from some experimental studies. Okay. And the new values, whatever we are going to do, how will we get the new values? Like I said, yes,
Mathematical expressions.
mathematical expression. So expression like this. So this is the new values for the new compounds we are going to estimate by our model. So initially we are having the value experimentally and then model. So this is why you can think like what you have to do with it. Then the next thing is I would say X1 or something, all these descriptors. All these descriptors, your X1, X2 or whatever. So if I say what you are going to get experimentally, the activity values, initial values you are having. So similarly for this to develop the model, the initial values of descriptors, from where are you going to get? You want to come up with these models. So experimentally the Y values you need to know. Similarly, the descriptor values from where you are going to get? From experiments. It is written from experiments. Okay. So experiments, it is correct. But suppose if you don't know the values of descriptors from the experiment also, by knowing the structure, if you know the structure of the compound about whatever you have done the experimental study, also using this chemical informatics software also, you can do this. This is what I had mentioned in this particular slide, that the molecule you are having. So experimentally you can predict the molecular descriptors, or using your theory or computational studies also you can predict, so that you can do the QSR study. Okay. So this is okay. that x1, x2 also you can do. And if for the new compound, if you want to get the values of the molecular descriptor, then the option you have, again, you can go for the experiments, but that we don't want to do. We don't want to again spend time with the experiments. With the faster way, we want to predict. So this will be the use. So here for new compound, you are going to use the model, and then for new compound, you are going to use some software to predict this molecular descriptor. So that day I mentioned the softwares like Paddle, you are going to use it here. Then the next thing is, there is something more that you need to know so that you can complete this task. So there are these constant A0, A1, A2. How you are going to estimate the constants? Does anyone have any answer? However, this we haven't discussed. Okay. So this we'll see today. We are going to use a method called as regression, and using that we are going to do this. So the assignment number 2, what I'm going to give, this is related to this descriptor, and I said you are going to use this thing. So this is also going to be a simple thing. So what is the assignment? First, I will explain to you. Okay, so that day I showed you this research paper, right? I said that QSR study has been done for calculating the antibacterial activity for some sulfur drugs. So you have this general structure for the sulfur drug, and if you vary the R group, so you can come up with so many different sulfur based drugs. Now why only these only 6 compounds has been studied, why not all other? This type of question should come into your mind, so that this is something part which is related to us in our later studies. Right now just consider that these 6 compounds has been chosen due to some reasons. So these 6 compounds are for your assignment, and you should be able to calculate first the molecular descriptor for all these 6 compounds. Okay. So just okay. So that I mentioned to you, you should use this software for Paddle. Again, I'm repeating, you have to download the software by going into this website. This I will share to you, but something like you can know, even if you simply type, don't just type Paddle descriptor you type, and you will get the first website. So there you have to go. And if you go here, I said there are 2 options, but please click here. Otherwise, different people might also get different values, which you don't want. So I said you have to download this software. You will get it into zip file. You have to extract it, and after extraction, your paddle descriptor should be. It should show like this. So you are not going to install or something. Just it will be a directly. You can double click and open it. So this Java should be downloaded on your computer. So it will show the icon like this. Otherwise, it will show this. If it is showing this, then you should first take care of your Java. Otherwise, it is not going to open. Okay, it should. So this is your assignment. I said like whatever the structure, 6 structures are given to you, compound number S1 to S6 in paper. For that compound, you need to calculate the molecular descriptor. When you double click onto the software, something like this, the software will open, and using this, you can calculate, I think more than 1,000 molecular descriptors. So these 4 molecular descriptors you should calculate: W path, which is binary index, molecular weight, then X log P, the water octanol partition coefficient, and AMR, which is the molecular refractivity. So what you have to do, just take a Excel sheet. In Excel sheet for this S1 to S6, make 6 rows. Write down the name of that compound from the paper. You can copy paste the structure of that thing from the paper itself. You don't need to do anything related to camera or something. just you take care of the smile string. Like for all these compounds, you write down your own smile string. While doing this, you should know that for all the six compounds, the general structure is same. The general structure, only the R group is different. So what you can do up to the R group, for everything the smile string will be similar. Only for the R group it will change. So in the end only it should change. If you are simply copy pasting it from somewhere from the internet or something, so I will figure it out. So you what you have to do, you have to put your own efforts while you are drawing the smile string for your compound. So for all the six compounds, the initial smile string should be similar, and only for the end R group it will be different. So this you please do it yourself. And then you have to fade it into this software, whatever the PDB file. I think this software Paddle takes the PDB file. So for all six compounds, you save the PDB file using OpenBabel or something, and then you fade it into the software, and the software will generate these molecular descriptors. Okay, so this is what you have to do. You have to write down the smile string also in your um, assignment, the Excel sheet, and you are going to eval whatever values you will be getting through the software. This you have to put it into this Excel sheet and submit it me like as similar to the previous. Here I have mentioned next Wednesday. This I should this just a minute. Just change to Friday. Next Friday, I think that was sufficient for you. And submit all these things. So along with this Excel sheet, whatever for your four compounds you are going to generate one file, that also please attach. So two files you have to attach. Okay, so now how to do this using the Paddle software? Let me show that. Okay, I hope this is visible. The Paddle software which I had installed. Inside this, I have already extracted. Suppose instead of your zip, that WinZip icon, no, if you have simply, if you don't have that software in your computer, and if it is showing like this change, so then you have to just right click, and again you want to do the extract all. So extract all if you do, and if you do extract, so this again same folder will be extracted here. So then you can double click and see the content of this folder. So if you see this here in my computer, it is showing this Java icon. So I can double click on this, so it will open. I hope you can see this. So is this software visible to you? Paddle descriptor. Guys, you need to be little bit active. There are 31 people if I guess, and none of you is
Not
replying.
visible, sir.
Not visible. This paddle descriptor is not visible. Okay. Select content. Okay, now I guess it is visible, right?
Yes,
Yes,
sir.
sir.
Okay. So what you have to do again, just the molecules directory file. If you click here, initially you won't see where to click and from where to browse. So actually here you have to literally click on this molecular directory file. Then only these three dots, which you can understand to be for browsing your files, that will come out. Otherwise, it doesn't show anything. So please click it somewhere here. So when you do this, so that day we have learned something about the Wiener index, right? And I had given you the example of N-butane and isobutane. So those two PDB file I had already created using OpenBabel. So if you see that, just a minute. 1 minute, this is little bit hanged. Okay, so I hope you can see this here in the molecules underscore paddle. I already have PDB file for N-butane and isobutane. So even if you have, I think, more than 10 or 100 molecules, you can do the calculation at once for all the compound. You just need to put all your PDB file in only one directory, and just you have to select this directory. Okay, and then once this is selected, so descriptor output file. So here also you have to click manually, and then if you browse this, so they ask where do you want to save this. So in the molecules paddle, you can give any name like output. If I am giving here, so it will save a file. I guess you can see all these things whatever I'm doing. So output, I'm typing, so it is going to generate some file called as CSV file. So one instruction for you, this CSV file, sometimes the antivirus deletes it. Okay, so make sure if it is happening that the file is not getting generated, or even after generation you are not able to see that in the saved folder. So you need to something, you need to turn off your antivirus for some time, that you need to do. Okay. So if you see, I have to just do save. So with the name output.csv, the file will be generated. So here they have given so many options related to descriptors. So 1D and 2D, there are 3D descriptors also, something called as fingerprints, so many other things. So these fingerprints and other things you will learn later. Right now, just consider for your assignment, this 1D and 2D is sufficient. The descriptors are sufficient for you, and you do not need to do any other things. Okay, what else are default option, it is considered, it has considered, so just have that. And what you have to do, just click on the start. So in the fraction of second, if there are just a less number of molecules, so it will finish quickly. If you have more than 100, it will take some significant time. So you should consider that your calculation should finish in the fraction of second if you are just having 6 compounds. If it is just that earlier you have seen the some loading thing happened. So if that happens for longer amount of time, so consider that something it got stuck. You have to try to do it again by scratch. Okay. So once this is done, so I will show you this output.csv file. What does it contain actually? So it should contain some information related to this molecular descriptor. Just a minute. Okay, I hope this file is visible to you, the Excel sheet.
Yes, sir.
Okay. So here you can see there are 4 lines which are coming in terms of values. So actually you should consider the last 3 lines are repetitive, but these are the values for just one compound. And first line you can see some different values. This is for one compound. So I think maybe it takes alphabetically what are names you are having. So maybe it is showing the values of isobutane first and then the values of N-butane. So if you want to see this, what are these values for? So like compound here for 2 and 3 you can see for all the things it is showing some value, like for A log P it is showing 1.0124, and then here. So there is another Excel sheet which is actually present within the this paddle whatever you had extracted, no? So within this paddle, can you see this? The paddle descriptor folder, can you see this? So here you can see the descriptor. This is by default the Excel sheet is there. Okay. So if you open this descriptor sheet, So here you can see what are the nomenclature, all the different molecular descriptors. I hope you can see this descriptor type, number and descriptor. Can one please reply?
So,
Yeah. So here you can see like there are description like acidic group count. So for this, what is the short form they have used? So an acid. Similarly, you can see for this A log P and so many other things like that we have shown seen something called as this Wiener index. Here it has been shown by Wiener number and the acronym for that it is given as W path. Okay. So this is for binary. Similarly, X log P is there and so many other things. So in the assignment, I have asked you to work on like I think molar refractivity. So molar refractivity is somewhere here. The AMR. Actually, if you see this particular sheet here in the first one, they have just given the summary of all these things. But if you want to see in detail, like AMR, the detail, if you want to see, you have to go into this detail tab. So you can see. The for AMR in this A log P, what you had seen earlier, there were three terms A log P, A log P2, and AMR. So in the AMR, you can see this means something called as molar refractivity. Okay. So for anything you want to find out, like suppose just molecular weight is here. So I think for that I already know the term. So there is something called as MW. So MW, you can see weight is given. If you go into the detail, so you can see here that MW means molecular weight. So this should be there for you as the reference, like which particular name in what that CSV file is generating is belongs to like what category. So let me show you the Excel sheet that we have generated. So I said this is the Excel sheet that your uh, software paddle has generated. So suppose if you want to see here molecular weight, I'm just going to search for MW. Now if you see here the MW, there are so many different names. These are not the molecular weight. If you go into that detailed thing, if you see here the MW is somewhat little bit late here. You can see it. The 58.07825, they have given this as the molecular weight. Okay, so do you think this is the correct molecular weight for butane? For N-butane, isobutane, it will be the similar. So for C4H10, you can consider 48 plus 10. So it is showing you some correct value of molecular weight. So this should be your first step. If you want to just figure it out whether for your particular compound the software is calculating the values correctly or not, I would say you can just start from the molecular weight or something, just see whether the values are coming correctly or not. If you are confused between which particular line is for, I said last three lines are similar, it is just for one particular compound. I don't know how it gets repeated, but for between the two things, if you are seeing the difference, and if you are not able to figure it out for which compound it is doing, so do individually for each compound, so you will come to know. So similarly, if you go to W path, which is for the Wiener index I mentioned, so you can see as earlier also I mentioned that Wiener index for your N-butane was 10 and for your isobutane it was 9, so it is showing here. So if you go through that research paper, already the values of some of the molecular descriptors are already given. So for those six compounds which I had showed to you earlier, if you just want to verify whether whatever values the software is calculating correctly or not, so for this six compound, they have given this table, and I hope this is also they have calculated using some software. So you can compare this W here, it means the binary index. So for compound number S1 to S6, you can actually compare the values. Instead of asking to me or something whether your answers are correct or not, you have this for your binary index. Okay, so whatever structure you have drawn, the smile string you have mentioned, so you should calculate the values and compare with these values in the research papers, at least for the binary index, so that you can at least have some thought that whether values whatever you are getting is correct or not. Okay, so I hope based on this you can do this assignment. Then once you are able to do this calculation of molecular descriptor Something similar assignment I will be based on this paper only, which will be for identifying the best possible compound based on this study. So any doubt till this part? Just a minute. Okay, so earlier I had written in the slides the three things. If just yeah, y is equal to a0 plus a1 x. So I said activity you get from the experiment or you predict yourself using the model, x you get from the software, and this a0 and a1 is something which you should know so that you can figure out the value of y. So you don't know what about the constants. So I said this QSR modeling, you are doing this equation you are going to use, and you are going to use the method called as regression. Now what is the regression method? Does anyone have any idea? Have you heard of it before? What is regression? Okay, so I can guess that you don't know. So you might have heard about interpolation. What is interpolation? Okay. Here I have written to estimate the intermediate values between the precise data. Suppose if you are having any two data points, okay, like here I have mentioned, and if you want to know any intermediate values, so what you do is interpolation. Suppose for both the things, you can have something like first order interpolation, like linear interpolation. So using this, you can find out the middle values. Similarly, if your data, yes,
Sir, we can able to see Excel sheet only, sir.
you are not able, yes, that's what I was saying, like just a minute. Okay, I hope now you can see. So this is what I said, y is equal to a0 plus a1x, this kind of equation, this is the simplest equation you can have. So I said y and x you know, a0 and a1 you don't know how to figure it out. So we are going to use this method, like to derive these QSR models, we are going to use the technique called as regression. So for regression, what is the meaning of regression? You should know what is interpolation. So in interpolation, you try to predict some intermediate values. If you know, suppose two data points or three data points, you figure it out the intermediate values using this first order interpolation or second order or third order interpolation. So suppose if you are having two data points, you simply draw a straight line, so that you call linear interpolation. If you are having multiple things, then you go to the parabolic or other levels for the higher order polynomials. So in these cases, whenever you try to predict the intermediate values, the line always passes through the points. Okay, this is what the difference you are having when you do the regression. You should consider that same concept you will be using, that you want to predict the intermediate values, but now consider that you are having like there is substantial error when you are having a lot many data points, and you are having like so many data points, so that like if you try to do something like this linear interpolation, if you try to connect the data points like this, and if you try to come up with the model, it is going to be very difficult. And while said that, like you have to also consider that each and every data points also you have to take into consideration, so you cannot skip that. Many of the times in your lab studies, when you do some experimental thing and you have some values, like so many times you have some your y values and x values, you draw the plots, and for these different plots, what do you generally do? If I ask you to get the slope for this particular train, what do you normally do in the lab? Suppose if I want to identify the slope of this curve, what do you do
We
from
will
this
find
data?
best fit curve. Then we want to find the slope.
Yeah, so how will you get the best fit curve?
By the points which are, I mean to say, minimum errors.
Errors. So many times the shortcut that we use in the lab, like we take any two data points, if you know the thing, or we try to take all the data points and some imaginary line we draw, or some people take just the two data point and they try to draw the line. Whatever it comes, that you get the value as the slope. So do you think what you normally do in the lab is it is the correct way? So this regression, it is in general useful anywhere. Like even if you go to your any companies after your BTech, there are also so many places you can see that they will be using the regression, but they care about the accuracy. When somewhere you draw the line by considering anywhere, then it is not somewhat the accurate thing you are doing. And then I said the QSR modeling you are doing, so you want to get as accurate values as possible. So that will be only possible if you are doing it in the correct way. So if you are having the data points like this, so here the line cannot pass through each and every point, but it should come through the, it should take care of each data point, but it will move from somewhere at the center of each and every data point. So when you try to do that, this line which is coming from each and every data point, by considering each and every data point, so that is called as something called as linear regression. Means here we are drawing a straight line, so we are going to do the linear regression. Here you can consider if you try to do this kind of interpolation, this would be inappropriate. So we'll start understanding how to determine these values of your A0 and A1, which are the constant values, by simply considering the simplest equation. So the simplest equation that you can have, it will be the linear regression. So here you can have the equation in the form of, if you are having the data as yi and xi, suppose for in our cases the biological activities you already know, and the molecular descriptors you have already or calculated by the software. So this data you already have. So you can do, if you see that the trends of your data is something like there is a linear fit can be curved, so you can fit the linear regression. If your data points are coming like the polynomial fit, so you have to fit the polynomial regression curve. So suppose if you are trying to fit the linear regression curve, so your equation will be y is equal to a0 plus a1. This can be simply like the straight line equation, y is equal to mx plus c. Now, whatever you do, like if whenever you try to feed this data to your existing data points, okay, always you can consider that whatever line you are considering, this line, it is going to have some error associated with it. This error you can consider like this line, whatever you have drawn here. If you consider this particular data point, there is some difference from the value that you have predicted as the model for y and the actual value of y. So some error is associated. So this error we can little bit tweak this equation, and you can write this same equation in this particular form: E is equal to y minus a0 plus a1x. So here you can consider this error is nothing but what you had some true value. You had some value from the experiment that was your true value, and you are subtracting it from the value of y which you have actually estimated. So this is actually the true value, and this a0 minus a1x, you can consider it to be a0 plus a1x, which you had earlier predicted, some model you have considered and that you are using. So both are y. One is the true value, another is the predicted value. So you have to take the difference between the both the values, so that will become E. Now this error, it is either you call it simply error, or people call it residual value. So this value is important to figure out the values of A naught and A1. Okay, so how to figure out these values? So what you have to do to figure out this value A0 and A1, you have to consider some criteria, and this criteria you can call it the criteria for the best fit. Means what should be your criteria when you are saying that the line is fitting to the 100% level? So what should be the criteria? What will happen? The line, if it is fitting to each and every data point, means what? In terms of error, the error should be zero, right? That should be the baseline that you can have. So suppose if you try to figure out that error, and I'm calling the earlier error what I said as E of some I, means I'm going to calculate the error of for each and every data point, and this what I'm going to do for each and every I. So I's will be changing from 1 to n, what a number of data points you are going to have in your system, and this I can calculate as the difference from the true value to the predicted value. All the predicted values are here. A0, this value you can call it A0 plus A1 XR. So when you are saying for each value, so when you are going to sum for all of them, so you are going to get the summation as E of I, summation I is equal to 1 to n. So this will be the summation of equation. Now for this, I have written something like this is the, if you try to figure out the values of A0 and A1 using the equation like this is something like the inadequate criteria you are using. This is not going to solve your purpose for estimating the values of A0 and A1. Can anyone guess why this criteria is inadequate?
Because we want two equations, no, sir, two variables.
Two variables. Okay. I should say like there is some other reason for that. Means always you will be needing the equations for A0 and A1 as two different equations that you are going to solve something like in the way of simultaneous equation. But if you are trying to get the concept of error, and using this concept of error, if you are trying to figure out the values of A0 and A1, so this particular criteria, it is not sufficient. So in this particular criteria, what we are doing, we are calculating error values, and if you see the values of error, we are going to calculate what will be the value of error. If you try to take the baseline feed, and if you calculate this summation, what will be the value of E? If you see for each and everything, if it is equally passing from all the data points, like that summation of errors will be what? It will be zero. They say any straight line passing through the midpoint connecting this line results in a minimum value equal to zero, because everywhere this error will be cancelled out from the opposite side if it is passing perfectly. Okay. So if you are trying to get the error values in terms of this, so your equation cannot proceed anywhere else. So there is some other method that you have to use. This method actually it is called as least square regression method. From the name you can consider that earlier what are inadequate criteria we have, that for the errors we have tried to take here the square of the errors. So if you have taken the square, what is going to happen compared to the earlier thing? If you take the squares, so compared to the earlier equation, suppose if you would have tried to take this as the equation for solving. Okay, so somebody has written all the errors are positive here. Okay, so whenever you see this EI square, so you have taken the difference yi measured minus yi model. So you have done the square of each and every term. So earlier all those things were simply cancelled out, but now the magnitude of each and every error, whatever you are taking the difference, if you take the square of that, so that will come to the positive number. Earlier the positive and negative thing were cancelling out and making it zero, but now all the positive or negative thing will be eventually squared, so they will be converted to a positive number. So this you can consider as some of the criteria that will be useful for you for this A0 and A1. So this we are calling it as SR. Some this term will be important to you if you want to later on predict not just the job for you is not just the development of the model, but you should be also able to evaluate its accuracy. So for estimating the accuracy, you use some coefficients. So these coefficients like SR will be useful to you. So this SR, it is called as sum of squares of residuals. Okay. So when you are having this SR term, this you can write like this, square of this. So this should be minimum. That should be the criteria for your best fit, right? The term SR should be minimized. So what you are going to do to minimize this SR value? You have this one equation, and using this you want to predict the coefficient A0 and A1. So what can you do to predict these coefficient values? So I mentioned here this term needs to be minimized. So when you are saying this term needs to be minimized, so what you can do some differentiation, and accordingly you can set the derivatives to 0. So if you take the derivative of this SR, like you can take the derivative for estimating the values A0 and A1, take the differentiation with respect to A0 and A1. So if you differentiate this, you get something like minus 2. This 2 will come here and the negative sign from here. So it will become minus 2 and summation of this term. Similarly, if you take the differentiation of SR with respect to A1, again this minus 2 will come here, and as you are differentiating with respect to A1, so this minus symbol and xi also will come into picture. So you will get these two derivatives. So to want it to be the minimum, you have to set the derivatives to 0. So both the derivatives have set to 0, and you can get these two equations. So if you take the summation term outside for each and every term, your eventual job here is that all the equations you should be able to represent in terms of your coefficients A0 and A1. So if you see here, there are some adjustments has been done. Like for example, here summation of yi has taken outside. This will eventually become 0. This summation of A0 here, whatever you are having, this ultimately you have to convert to in terms of the coefficients only. So this will become n times A0, which is given here. This is summation of xi that is put into bracket, and this coefficient has been taken outside. So the equation becomes in terms of a0 and a1 and the summation of yi term. Similarly, the second equation a0 and a1. So you are having here two equations. Now these two equations you should simultaneously solve to get the values of a0 and a1. So if you get this equation by the some changes here and there, you can get the equation for your a1 and a0. So you can solve this in detail. There the A naught is dependent on the value average y and average x. So average x here is summation of xi divided by total number. So all these things you can actually calculate in one Excel sheet. So for example, now you know how to evaluate the constant values A0 and A1. Whatever way you are getting these values, you have to substitute that into your model. So your model will be complete. If you already have the values of descriptors, you know your activity value. So A0 and A1 values you can calculate. So for this one simple example is given here, that from compound number 1 to 7, suppose some simple values of uh, activity you are having. So you consider this to be descriptor, this to be activity. So whatever is needed in your equation for A0 and A1, like for example, summation of xi square, summation of xi yi, terms like this, or any other thing. So these you can calculate in the Excel sheet as xi square and other thing, and you can sum them out eventually. And these values of summation you can directly put into the equation. So this you can use this equation and your values for all the terms, and you can figure out the values of A1 and A0, so that finally you will get your models. So this is the basis for calculating the values of even A1, A0, A1 or water coefficients you are having. Once you calculate the descriptors from your software, and you can come up with the different types of models. So we'll slowly try to understand how to create the complicated equations. so that you can take into consideration your multiple molecular descriptors into picture, or if you are having any polynomial fit instead of a simple linear equation, so that we can eventually do that. Okay, so many times, just last sentence, like so many times they have said like we develop so many models together, so that for each and every model, like model number, all different models we are creating, we can estimate some coefficient values for all of them, and having the basis of this coefficient, we can tell which model is good. Only that particular model we will be using for our calculation so as to predict the best possible compounds. Okay, just this much for today. If you have any question, please ask. Or if there are no questions, you can do.
Hello, sir.
Yes.
Sir, after getting